Ladies and gentlemen, welcome to today's edition of physics. In this short video, we are going to investigate scientific notation. Scientific notation is an easy way, a convenient way for scientists to write really, really big numbers or really, really small numbers. For example, I can write this really, really big number in a more compact way. Scientists know that this and this mean the exact same thing. A really, really small number can be written as that. Now, it might not seem easier to you yet, but it will. All I'm really doing is moving my decimal. My decimal started there, and I want to bring it in between the 3 and the 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the 9th. My decimal started here, and I want to bring it between the 2 and the 3. 1, 2, 3, 4, 5, 6, 7. 10 to the 7th. You'll note when I moved my decimal that way, it became a positive power of 10. When I moved my decimal that way, it became a negative power of 10. This just means multiply the 3.679 times 10 to the 9th. 10 to the 9th is 10 billion. Lots of zeros. 2.35 times 10 to the negative 7. 0.00000000. Move it all over. When we have scientific notation, you'll note that you want one digit before the decimal. So we've got our ones place. Our ones place. You'll never write this as 36 times 10 to the 8th. We don't do that. We write 3 point something, or 2 point something, or 1 point something. It's never 10s or 11s or 12s point anything. We want one digit before the decimal place. Go ahead and convert 37,645 meters to scientific notation for me. That's what you should have gotten. Try another one. Take that really, really small number and add it in scientific notation for me. And that's what you should have gotten. Now, let's work the other way around. Expand out. If I gave you 3.8 times 10 to the 11th meters, write that out with all the zeros that you would need. I would much rather write that than that 100 times. Actually, I don't want to write any of them 100 times. I wouldn't do that. Expand that one out to what it should be. Yeah, no thanks. I'm not writing that when I could write that. Scientific notation. A more convenient way to write a really, really small number. Now, on your calculator, in order to get this times 10 to the, that means to a power 10 to the power, the exponent of negative 21 or 8 or whatever it is. You will never, ever use times 10 caret. Don't do it. Do not punch it in your calculator as times 10 caret because you will mess up when trying to do a division problem. I guarantee it because your calculator doesn't understand the order of operations that you're typing in. So, you will use the scientific exponent feature on your calculator. On most of our calculators, on your TI-80 whatevers, it's second comma, and the comma is above the 7, and it looks like a capital E. This means 10 exponent of 10 to the power of. On other calculators, there is an EE button. You find that and you press it. It's probably one of those two. If your calculator doesn't have these, come talk to me, come talk to Miss Wilk, find somebody, bring your calculator and say, how do I do this? But do not, for the love of all that's good and holy, do not use times 10 to the caret feature. You will get it wrong on division problems. So if we wanted to multiply 3.8 times 10 to the 7 by 4.8 times 10 to the 6, you type in your calculator 3.8 second comma, and you get the capital E times 7. Don't use the lowercase e. That's a natural logarithm. Don't use it. Use the capital E. So you type in second comma gives you that E 7 times second comma gives you the E 6. Enter. So your calculator string will look like that, 3.8 E7 times 4.8 E6 if you're doing it right. When you do that, you hit enter, and you get that on your screen if you're doing it right. Now your calculator screen uses an E, you don't get to. You get to write out on my test times 10 to the. I don't want to see E's on there. That's the lazy person's way to do it. Say, my calculator gave me an E. Well, you know that that means times 10 to the, so you write that out. But we need to keep into account sig figs. I got 2 here, I got 2 here, I got 4 there. No, I can only get 2 still. So that's going to be 1.8 times 10 to the 14 as my answer. All right. If you didn't get that, punch it through your calculator again. If you can't see how to do it, come talk to me, come talk to Miss Wilk about it. All right. Let's try a couple more. Punch that one through. What'd you get? And when I did it, that's what my calculator reported out. Those are all the numbers. I don't want to write down all those numbers. I want to put it in scientific notation. Before I do that, I need to look at sig figs. What this is telling me, this mathematical operation means 4 to add 7 zeros minus, that's what I'm physically doing in my calculator. So in this one I've got 2 digits here, I've got 2 digits there. But remember, with addition or subtraction, it's the place, the digit that matters, not the number of sig figs. So this is my least precise, my estimations point, so that's the digit place that I'm going to go to. Well, that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This little 3 is my significant digit that I'm allowed to go to, so I'm going to report this out as 4.163 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. But watch your sig figs, right? Here I've got, you got to think about how many sig figs do I get when I add or subtract. You did it right. Now we multiply them. What do you get? Now your calculator is going to spit out 1.554 times 10 to the 15. Am I allowed to use 4 sig figs here like I've been doing up above? Well, no, because now this is multiplication. I got 2 sig figs here and 2 sig figs here, so I'm only allowed 2 in my answer. Round up the 5 to a 6, 1.6 times 10 to the 16. Lastly, do a division. Lastly, try with division. What do you get? That's what my calculator spit out. I'm not allowed to do that, though. I'm only allowed 2 sig figs. 2. I'm only allowed 2. So I could write that as 1.1 times 10 to the second, or 110. Either one of those will be fine. Sig figs, you got to know how to do them. Most people, when I told you, said, yeah, I just need a little refresher. This is your little refresher. If you need more than this, come and talk to me. Come and talk to Miss Wilk. Come talk to somebody in the chem lab.